in a suitable chemical reagent and then precipitation of metal by a more electropositive metal. For example, gold are extracted by hydrometallurgy. So, hydrometallurgy is the process of extraction of metal from their ore by dissolving the ore in a suitable chemical reagent. Electrometallurgy. Electrometallurgy is the process of extraction of metal from their ore by passing electricity. Electrometallurgy involves metallurgical processes that take place in some form of electrolytic cell. The most common types of electrometallurgical processes are electrowinning and electrorefining. Electrowinning is an electrolysis process used to recover metals in aqueous solution, usually as a result of an ore having undergone one or more hydrometallurgical processes. This is the picture of electrometallurgy. Extraction of metal. What are the methods for the extraction of metal? First is crushing, grinding or pulverization. Second is concentration of ore. Third is extraction of metal from concentrated ore. And the fourth step is purification or refining of metal. So first of all we will discuss the pulverization or grinding or crushing of the ore. Ores found in nature are usually bulky in size. They are crushed to small pieces with the help of jaw crushers. Ores they are found in bulk in nature and they are crushed to small pieces with the help of jaw crushers. These pieces are further crushed to the size of sand with the help of stamp mills or rollers. These pieces they are further crushed to the size of sand with the help of rollers. So, this process is called pulverization. These are the jaw crushers which are used for grinding the ore. Another picture of jaw crushers. Second step is the concentration of the ore. The ores obtained from the crust of earth contain earthy impurities like gravel and sand. These impurities they are known as gangue or matrix. The gangue is to be removed to get the pure metal. Depending on the nature of the ore and gangue, different methods are used for removing the impurities. This process is known as concentration of the ore. What is concentration of the ore? The process of removing the impurities from the ore is called concentration. Some important methods are used for concentration. First is washing. Second is froth flotation. Third method is magnetic separation. Next is leaching, roasting and calcination. First step is washing in a stream of water. When the density of impurities is less than that of the ore, this method is used. This method is used when the density of impurities is less than that of ore. When the powdered ore is washed in a stream of water, when powdered ore is washed in a stream of water, the floating impurities will be washed away and ore will remain underneath. Second step is gravity separation. The separation is based on the difference in specific gravities of the gangue particles and ore particles. The powdered ore is agitated with water. The powdered ore is agitated or with water or washed with a running stream of water. The heavy ore particles, they settle down while the lighter particles of sand or clay, they are washed away with water. For this Wilfley table, this is a Wilfley table, this table is used. It is a wooden table having slanting floor on which long wooden strips are used. They are called rifles. They are fixed. For example, hematite ore. Second step is froth flotation. If the density of the ore is less than that of impurities, this method is used. If the density of the ore is less than that of impurities, then this method is used. Here the powdered ore is added to a mixture of pine oil and water. Ore is added to the mixture of pine oil and water. This is stirred by a strong current of air. Pine oil, it forms froth, and ore wetted by pine oil floats with it. From this, it can be easily removed. This method is used for the concentration of sulphide ore, for example, Galena, PBS, and copper pyrite, CuFeS2. Next step is magnetic separation. If the ore is magnetic, it can be separated from impurities by passing through a magnetic field. The magnetic ore is attracted towards magnet. What happens? The powdered ore is allowed to fall over a belt. This is a belt which is moving over the magnetic. These are rollers. The powdered ore is allowed to fall over a belt moving over magnetic rollers. The magnetic impurities fall from the belt in separate heap near the magnet due to attraction, whereas non-magnetic impurities form separate heap from the magnet due to the influence of centrifugal forces. For example, chromite. Next method is leaching. This method is used when the impurities are insoluble but the ore is soluble in a solvent. When powdered ore is added to the solvent, the ore reacts with the solvent but the impurities remain unaffected. This type of concentration is known as leaching. The following reaction shows the concentration of bauxite Al2O3, 2 parts of water molecule plus sodium hydroxide, sodium meta-aluminate is formed. Its formula is NaAlO2, and from this aluminium it gives aluminium hydroxide, and on heating it gives pure alumina. Bauxite reacts with sodium hydroxide to form sodium aluminate. Next is roasting. Roasting is carried out in reverberatory furnace. It consists of floor on which charge is placed, a hearth where fuel is burnt, and chimney for the exit of waste gases known as flue. The ore is crushed and heated in a strong blast of air. The ores are converted into their oxides. The ore is oxidized by oxygen present in air. Here, sulphide ores undergo oxidation and change into their oxide. Sulphide ores, lead sulphide, on oxidation it gives lead oxide PbO plus SO2. Zinc sulphide on oxidation it gives zinc oxide plus SO2. Its formula is ZnO. Next is calcination. When the ores such as calcium carbonate is heated either in the absence of air or in controlled air stream, the following reaction takes place. Calcination is done in the absence of air. Calcium carbonate gives calcium oxide plus carbon dioxide. Volatile impurities are removed by this method. Next is smelting. Ores after roasting or calcination is mixed with coke or charcoal and heated strongly. Ores after roasting or calcination they are mixed with coke and heated strongly. Metals like zinc, iron, nickel and lead are prepared by this method. For example, SnO2 plus carbon gives Sn plus CO carbon monoxide, PbO plus carbon lead oxide it gives lead and carbon monoxide CO. Carbon monoxide evolved can cause reduction of ferric oxide to iron. Carbon monoxide evolved can cause the reduction of ferric oxide to iron. FeO3 plus CO gives iron plus CO2. The ores thus obtained may still contain certain impurities which can be removed by adding flux. If gangue is acidic, basic flux such as lime, if the gangue is acidic, for example SiO2, basic flux such as lime CaO is used. If the gangue is basic, acidic flux is used. The flux reacts with gangue to form slag. The slag floats over the molten metal as its density is less than that of molten metal. Next is reduction with aluminium. Metals like manganese, chromium, vanadium can't be extracted by heating with carbon as they form their carbides. Such metals can be prepared by reducing their oxides with aluminium. Chromium oxide plus aluminium, Al2O3 plus chromium is formed. This method can be used for preparing metals which are less electropositive than aluminium. So this process is known as aluminothermy. Reduction with hydrogen. If other reducing agents are not effective, hydrogen is used. Tungsten oxide plus hydrogen gives tungsten plus H2O. Refining. The metals produced by the above methods will still contain impurities. The process of removal of impurities from a crude metal is the third step in the production of metals. Liquation. Refining of metals. First method is liquation. Metals with low melting point, for example lead, tin, they are heated on a sloping hearth of furnace and allowed to flow away from infusible impurities. The metal melts and flows down, leaving behind non-fusible impurities on the hearth. Pure metal is collected at the bottom. So today we have discussed metals, non-metals and metalloids, flux, slag, gangue and the methods for the extraction of metals. That's all. Okay, thank you.